Okay, so let's pick up where we left off. So with this on page 5, in this example, we're finding the domain of each function, and then we're going to write our answer in interval notation. So part A, this function right here, this is just a linear function. So its graph is a line. So I can plug anything I want in for x. There's no restriction. So the domain is negative infinity to negative infinity. What you're trying to look out for are cases where you have like an x inside of a radical, or where you have x in the denominator, the trig functions, and then also like the logs. So you don't know, we don't have a lot of functions that really kind of mess up the domain. So if it's not one of those, then your domain is pretty much all reals, or negative infinity to infinity. So for the second example, for B, again, x is not in a radical, it's not in a log, it's not in a denominator. You can plug anything you want in for x, and you're always going to get an answer. Nothing makes it undefined. So negative infinity to infinity. So part C, now we got a radical. So okay, let's think about this for a second. What kind of numbers can you have inside of a square root? Well, you could have 0 or positive numbers. So that means the inside of the x minus 5, it has to be greater than 0, so it's positive, or equal to 0. So for the square roots, just take whatever's inside of there. And again, it doesn't matter what's inside of it, just rewrite the inside, set it greater than or equal to 0, and then solve for x. So x has to be greater than or equal to 5, and as an interval that is 5 to infinity. Okay, for the next one, 6 minus x, it's got to be greater than or equal to 0. So you can move over the 6 divided by -1, or move over the x. So 6 is greater than or equal to x. So 6 is the biggest. So negative infinity up to 6. If you're not sure if your answer's right, just pick any number you want that's inside this domain, or inside this interval, plug it in for x and see if it works. So like if you picked 5, 6 minus 5 is 1, that's okay. So this is good. Okay, now for these, when it's rational, you have an x in the denominator. Look at the denominator and go, okay, what makes that actually equal to 0? And whatever you get, that's what you can't use for x, because you never want a 0 in the denominator. That's bad. You can't divide by 0. So the one number we can't use is -1. So x can't equal -1. So in interval notation, that would be negative infinity to -1 with a parenthesis, like don't include it, union -1 to infinity. So you're skipping over the -1, but it can be anything else. So for f, again, you're really only paying attention to the denominator. You can't plug in a -7. The numerator can be 0, that's okay, just not the denominator. So x can't equal -7, and you can either, you can write that or think it in your head. So negative infinity to -7, union -7 to infinity. And then we come across ones like example G. So here, you could factor it. And once it's factored, just go, okay, what makes it 0? -3 and 3. Now some of you were going, wait a minute, you can cancel out the x minus 3s. Well, yes, you can, but the domain is always governed by the original function, not what you simplify into. So yeah, you can cancel them out, but you want to get your domain before you cancel them out. So personally for me, I just factor it and leave it and go, okay, what's my domain? Get that, and then if there's anything else to do, then I could proceed. This one, there's nothing left to do. Just get the domain. So we got to skip over -3 and 3. So negative infinity to -3, union -3 to 3, union 3 to infinity. All right, part H, there is an x in the denominator, but you're squaring it. So if you plug in any number in for x other than a 0, you're going to get a positive. Well, positive or 0 plus 1 is still positive. So the denominator can never be 0 no matter what you plug in for x. When you have a positive plus a positive, that's never 0. So you can plug anything you want in for that function. Okay, now this one, now it's a combo. You have a radical and rational. It's a merging of the two. So let's figure out the domain of the radical. Excuse me. So if we follow the same thing, that would be 1 and higher. Right? But the denominator says, well, you can't use 5. So 5 is in this interval right here. Well, if I can't use it, I have to pull the 5 out of that interval. So I have to skip over it, just like I did with this one, or this one. So I can still start at the 1, but I'm going to go all the way up to 5 and skip over it, and then keep going. So if it's a combo, if you have a radical inside of a fraction, you got to be a little bit careful. So the radical is still going to really restrict the domain, but the denominator will restrict it a little bit further. All right, let's stop the video here, and we'll continue on with these difference quotients in the next one.